We're now going to talk about what I call the Magnificent Seven. There are 7 basic shortcut rules that can be used for finding the derivative of different types of functions. These rules were developed again from that formal definition where you took the limit as h went to 0. And so they give us a foundation, and then all of the other derivative rules that are developed come from these 7. In this course, we will also go over some basic formulas for derivatives, but there are many derivative formulas that we're not going to touch on, but if your career or further studies ever needed them, it's simply looking up in a reference manual the formula for the shortcut for the derivative. So let's get started. A couple of these we already know based on our unit introduction, so we'll kind of run through those. Remember, the power rule says that to take the derivative of the power, and we can use y prime or f of x prime, we bring the power down front, we decrease the power by 1. Okay, so that's the foundation of a derivative. So doing this example, to find the derivative, we would bring the 7 down front and we would decrease the power by 1. So the derivative of a power function is bring the power down front, decrease the power by 1. The second rule is the constant rule. Here y equals k, k standing for a constant. And as we learned in the unit intro, y prime equals 0, because no matter what the constant is, it is a horizontal line, and the slope of the horizontal line is always 0. So whether it's positive or negative, the derivative is always 0. What's called the coefficient rule just simply says that you might have a constant out in front of a power. And so if you write it like that, you might see that basically just to take the derivative, you take the derivative of the power just like we did up above, but now we're going to multiply it to the constant. So it's really just kn x to the n minus 1. So to find the derivative in our example, we're going to do 4 times the derivative of x to the 8th. The derivative of x to the 8th is 8x to the 7th. Bring the power down front, reduce the power by 1. And so y prime equals 32x to the 7th. And the last rule that we learned from our introduction was the sum and difference rule if we have things added together. So if I have little mini functions added together, to take the derivative, you simply take the derivative of each little function and add them or subtract them together. So over in the example, to find the derivative of this, we take the derivative of 5x squared, which is 10x. We take the derivative of 10x to the 4th, which is 40x cubed. And we take the derivative of negative 9x, which is negative 9, because it would be x to the 0, and so there isn't any. And the derivative of 2 is 0. So our final derivative is 10x plus 40x cubed minus 9. Now this one over here looks a bit tougher, but not if we remember that x to the 4th in the denominator is the same as x to the negative 4th in the numerator. And so sometimes what you want to do is you want to rewrite it so that you don't have that fraction. To find the derivative, we multiply the negative 4 times 5, which gives us negative 20, but then we decrease the original power by 1. And this is where we often get major mistakes. And so this would be negative 20 x to the negative 5. So when you decrease by 1, it actually becomes negative 5. Likewise, we do 12 times negative 6 is negative 72. Decrease the power by 1, and I ran out of space there. And so that would give us minus 72x to the negative 7. Now we should, I'm going to come over here in red just so you can see where my final answer is. My final answer is in red. We typically don't leave negative powers, so we would want to rewrite that so that the x to the 5th and the x to the 7th are back in the bottom. So those are the first few rules that you learned in the introduction. Now we have what are called the product and the quotient rule. And the product and the quotient rule have a little bit more of a formula attached, but it's not too bad. Okay, and we did not discover these. These are a little harder to discover. So we will look at the formula. And the formula to find the derivative goes like this. We have two functions. We have a u times a v. So if you look over in the example, the first parentheses is u and the second parentheses is v. Okay, so we have actual little functions. You're going to take the function u and you're going to multiply it by the derivative of v. Then you're going to do plus v times the derivative of u. Okay. How you might also see this written, just so that you don't panic, is the function u times the derivative of v with respect to x plus the function v times the derivative of v with respect to x. I'm sorry, the derivative of u with respect to x. What I remember is that it's the first times the derivative of the second plus the second times the derivative of the first. So you got to come up with a way to remember it, but it's first times derivative of second plus second times derivative of first. Now what some people like to do is they like to do this, where they say, okay, what's my u, what's my u prime, what's my v, what's my v prime. And so they set that up each time, and you can or cannot do that. That's fine. So my u is my first little function that's being multiplied. So that's 3x to the 4th minus 7. My v is 5x to the 10th plus 3x squared minus 7. Now let's find the derivative of each. So this would be 12x to the 3rd, because we have to decrease, minus 7, the derivative of 7 is 0. Over for v, we would have 50x to the 9th, because I decreased my power, plus 6x, and the derivative of 7 is 0. So now to find my derivative, it is u times the derivative of v. The derivative of v is 50x to the 9th plus 6x. Plus v, which is all of this, times the derivative of u, which is 12x cubed. And so now we need to do some cleaning up. So let's FOIL this. That would be 150 x to the 13th plus 18x to the 5th minus 350 x to the 9th minus 42x. And now multiplying 12x cubed times everything, I'm hoping I can squeeze this in, 60x to the 13th plus 36x to the 5th minus 84x to the 3rd. And we can actually clean this up a little bit, so I'll use green here. We have a 150x to the 13th and a 60, so 210x to the 13th. So that took care of that and that. Our next one looks like it's minus 350 x to the ninth. The 36 and 18 can go together. I think that should be 54 x to the fifth. And then we have minus 84 x cubed minus 42x. So that would be our final answer. Now, I know that you're thinking, oh, that's a lot of work. Well, remember, you have a choice, and that is you don't have to use this method. You could do f of x plus h minus f of x all over h as h goes to 0, and you could plug that into using this formula or this function. So whichever way you prefer, but usually the product rule is a little less work. So again, you take the first function times the derivative of the second plus the second times the derivative of the first. The next one is the quotient rule. And the quotient rule is similar to the product rule, but a little bit different. The key here is for your function that u is on top and v is on bottom. Okay, so when we reference u and v, u is the one on top. So the derivative of a quotient looks like this. It is v times the derivative of u minus u times the derivative of v all over v squared. And the way that I remember that is it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So that might help you just put it into perspective. Alright, so again, some people like to take and figure everything out first and then plug it in. And some don't. Some of you want to go right to the formula. And again, that's fine. So the u is always the top, 3x squared plus 7. The v is always the bottom, which in this case is 4x minus 5. The derivative of u is 6x. The derivative of v is just 4. Now, to find the derivative, we do the bottom, which was v, 4x minus 5, times the derivative of the top, which is 6x, minus the top times the derivative of the bottom, all over the bottom squared. And so cleaning up the top a little bit, we get 24x squared minus 30x minus 12x squared minus 28 all over the bottom squared. Okay, so if we clean this up a little bit, we get 12x squared minus 30x plus 28 all over 4x minus 5 squared. So what you need to do here, you don't necessarily need to multiply 4x minus 5 out. What you do need to do is check to see if you can factor 12x squared minus 30x plus 28, and you only want to worry about factoring it if it factors into a 4x minus 5 so that we can reduce. And since it doesn't, then we just leave it like that. If the top would factor into a 4x minus 5, then we would need to do that and cancel those things out. So those are the basic rules through the quotient rule. I'm going to stop here and come back in the next video to do the chain rule. So I would encourage you to go practice these rules that we've gone over so far, and when you think you have those mastered, come back and watch the chain rule.